Hello everybody, Zero Fossil Fuel. I just wanted to show you real quickly the completed spiral cell. You can see how the nylon spacers, the nylon cable ties, I've allowed to protrude from one side of the spiral cell about 1/4 to 3/8 of an inch, someplace in between there, probably about 3/8, so that when I set it down inside the vessel, inside the tank, it actually sits off of the bottom so that the circulation can take place through the cell itself, and it's completely self-supporting that way. You can also see the adhesive that I've applied. It is just at the tips of the nylon spacers. It's goop marine adhesive and it sticks extremely well. I'm going to put it in the electrolyzer tank with just distilled water, and I'm going to measure the DC resistance and see if it was an anomaly with the capacitance value that I got earlier. Alright, this is kind of interesting. I'm on the 20k ohm scale, and I have my leads attached to the two plates. It's just in distilled water, and the reading is going steadily up, as if it was connected across a very large capacitor. And if I reverse the leads, notice it starts at a negative value, just like a capacitor would, and then it begins to go positive again. I'm going to change scales and go to the 2k ohm scale. And you'll notice, even on the 2k ohm scale, it charges pretty slowly. So it really does behave like a large capacitor. That's not exactly what I expected from this in distilled water. I expected it more to behave like a very small capacitor, 0.03 microfarads to be exact. Alright, I have a 0.05 microfarad capacitor attached to the capacitance meter, and it's reading 0.044 microfarads, which is within the 20% tolerance of the capacitor. And I wanted to see what happens when I take a 10k ohm resistor and put it across the terminals to simulate a leaky capacitor, and watch what happens to the value. The value actually drops. I thought it would go the other way, because I thought this was behaving like a leaky capacitor, and the anomalous reading of 0.03 microfarads that I was expecting was actually showing 2200 microfarads, a very large capacitor. So it's pretty obvious that just because I add a leakage current across my test sample, the meter actually goes the other way. So if it was just this being leaky, I would have shown maybe 0.015 microfarads as opposed to 0.03, which is what I expected. So I guess this really is 2,200 microfarads in distilled water. A very, very surprising result. So Aussie, you were right. And obviously the inductance that I'm going to need to tune this resonant circuit is going to be a very small inductance rather than a very large inductance.